Great to see everyone here. My name is Nicholas King. I'm a board member of the Center for Social and Cultural Data Sciences, a professor here at McGill in the Biomedical Ethics Unit, and the director of the Policy and Data Science program. And I am thrilled to have the opportunity to introduce Erika Braithwaite to you. Erika is one of the co-founders, along with the other co-founder, Catherine Morrison, who is also here today, and CEO of Precision Analytics, which is a Montreal-based startup that she will tell you all about that does data science with a broad range of public and private clients, everything from basic research to data science for pharmaceutical companies and so forth. Erika is an amazing human being, a former student of mine who I've known a number of years. Back in the day, even before Precision Analytics was founded, when it was just a gleam in the eye, maybe not even. Erika has had an interesting career that brings her to this point. She has a BA and a master's degree in psychology and a PhD in epidemiology and biostatistics from McGill University, which shows one of the many different trajectories that can take you into the data science world. Precision Analytics now employs 6 people, and I'm sure she'll tell you a little bit more about it. In her spare time, I can attest to the fact that Erika is an accomplished athlete, an amazing dancer, and just an extraordinary and impressive human being. So without further ado, Erika, take it away with, but I'm not qualified to be a data scientist, how to transition from university to the data science industry.
Can everyone hear me in the back? Yeah. I'm so excited to be here with all of you today as a fellow student of McGill and someone who transitioned with all the anxiety that you guys did too. So hopefully I'll be able to assuage that anxiety just a little bit. You'll let me know at the end of the talk how I did. And so if you're here, it's because you're thinking about leaving the welcoming womb of the academic setting and transitioning to a data science career. And so you're probably feeling super overwhelmed with all the possibilities ahead of you, confused about the terminology, insecure, likely about your own capacities, and just lots of emotions that a lot of people facing graduation are feeling. And so you faced data science because you know how much opportunity is out there. You've probably read the McKinsey report saying that by 2020, which is now, we're going to have this huge lack of data scientists. And most of you know that it's connected enough with what you maybe learned in university, but there's still so much more to learn. And so I'll do my best to give the most data-driven talk that I can and try to dispel some myths about the data science sector, about tips on how to transition if you're still in university or just thinking about the next steps. We'll talk about your CV, the job search, and the interview process, and hopefully bestow some glimmers of hope. So Nick gave me an incredible introduction. I don't think I agree about my dancing, but I am indeed the CEO of a health data startup here in Montreal. Yeah, okay. And I do have a background in psychology. I was really doing more research. I wasn't so much interested in being a clinician, so I really focused on sort of statistical methods in psychiatric research. And then I pivoted into epidemiology and biostats because I did want to dig deeper into statistical methods, but I wanted to retain sort of that substantive interest, which I had about psychiatric research and social policy. And so the company we founded, and I'll talk a little bit more about my journey, is with the wonderful Catherine Morrison. We founded it in 2017. We sort of began as a statistical consultancy, and then we sort of meandered into software, and we primarily work in the biopharmaceutical sector, and we create software tools that combine data storage, analysis, and communication. And so I'll tell you a little bit about our story. Personally, I maybe made it halfway through my PhD before realizing I didn't want to be an academic. And it was a bit of a crushing realization because I had no idea what else was out there. And so I went to CAPS, which is like the career services here at McGill, and I had a session with one of their wonderful career counselors. And just in the name of, I was like, I need to narrow things down. I don't know what I want. And I felt like in the PhD, halfway through, I didn't want to leave because I didn't want to quit, but I felt like I was racing towards an edge and I didn't know what was like at that cliff. And so she kind of walked me through the 5 main sectors that you can sort of work in. So we talked about the private sector, the public sector, government, academia, and entrepreneurship. And so we talked about my values and the things that matter to me. So, whether you want to make money, whether you want stability, whether you're risk averse or not, whether you have intellectual curiosity and you want to be able to let that blossom. And so through the process of elimination, I sort of ended up at entrepreneurship. But I can tell you in that moment, that meant nothing to me. I had no models of what an entrepreneur looked like or what could they do with a PhD. So I kind of left no more confidence in my path than when I began. But I sort of at the same time realized that I liked working with people, so getting me thinking about the things I like to do. So I like working with people and I like stats. And so I started offering tutoring services and consulting services to different people. So I was a broke grad student, and this was a great way for me to earn extra money. I teamed up with Catherine towards the end of my PhD because she was doing the same thing, and we were sort of exchanging clients. And then I finished the PhD, didn't know much more, sort of started a postdoc, and then the consulting was kind of growing outside of much bigger than, much faster than we thought. And we sort of started a company by accident. And when I realized how much joy it brought me to merge my interests of statistics and working directly with people to answer their questions and to see their faces light up when their data came alive, I realized I sort of found my path. And so we started the company as consultants, and we would meet with people and say, tell me about your company. And the first thing people jump to is like, well, I want to use random forests, and I want to AI all of my data. And it's like, okay, well, and our first question was like, well, tell me a bit about your data. And so most organizations, without a doubt, their data is disorganized. They're on maybe 6 different computers, different spreadsheets. People don't know the last version, CSV files called final, V2, final. And so we had to talk about that anxiety and what we called data shame. So lots of organizations had a lot of data shame. And so before we could do anything with their data in terms of analysis, we started building infrastructure to store the data, and then do analysis. And then a lot of our non-technical clients were extremely smart, but an output from any statistical software, basic tables, weren't really speaking to them and weren't really helping them make decisions. So we were like, okay, well, what if we built a web app? What if we built a tool that let you see the results of your analysis, let you interact with it directly? So build new plots, enter data, download it in different formats. And that's kind of how we stumbled into software as a service. So we blend consulting services to help people from the ground up understand what data they need to collect, how they need to collect it to answer their research questions, and then use software to automate the whole process and streamline it. And so that's our little company. And so back to the topic is that, so we do data science, right? Those pillars of storage, analysis, and communication. And we consider ourselves a data science company, and we know that it's this blend of math and stats, and programming, and then domain knowledge. And so I hope to give you guys a better sense by the end of it that it's really about storytelling with data. And I'm sure the reason that you are all here and the reason that you feel anxious is that this is a very real job posting that I downloaded maybe a month ago. And so you look up, on Indeed, and you see that the The job requires coding knowledge in several languages, C, C++, Java, JavaScript, knowledge and experience of statistical and data mining, GLM, and forest boosting trees, text mining, social network analysis, experience querying databases and using statistical computer languages R, Python, SQL, experience using web services, Redshift, S3, Spark, DigitalOcean, experience creating and using advanced machine learning algorithms and statistical regressions, simulations, scenario analysis, modeling, clustering, analyzing third-party providers, so Google Analytics, Site Catalyst, Core Metrics, AdWords, Crimson, Hexacon, Facebook, experience with distributed data computing, MapReduce, Hadoop, Hive, Spark, and so the list kind of goes on. And I can tell you right now, no one knows all of these things. Do not let these job descriptions freak you out. And I'll talk a little bit more about that, but this is where the anxiety comes from most people when they look at job postings. And so here I want to sort of dispel some of the myths in data science. From that job posting, you would think you would need a PhD in every topic, but you don't actually need a PhD to be a data scientist. A lot of the myths you hear too about like the popularity of Python, and so I want to dispel a little bit of the myth that Python is not the only tool that you need. I want to talk a little bit about how data science is not just machine learning and AI, and I want to talk about a little bit how data science is not just about your technical skills. And so to tackle these myths, I wanted to be data-driven, and so I downloaded Kagel's annual survey of data science. And so every year, I think since 2016 or 2017, they launch a survey through LinkedIn and Twitter and Facebook, and they ask people who identify as data scientists to answer this survey. And so I need you to understand first that there's a selection bias here because the Kaggle is a platform where people do machine learning competitions and for prizes, for monetary prizes. So there is a selection towards people who know about and use Kaggle. And so this is a very machine learning heavy crowd. So just a disclaimer. And so the data is available to download here, 2018-19, and the presentation I'll make available. And so just to give you a sense, the respondents were primarily from the US and India. And so that is just to give you a sense of like where people identify as data science are sort of located. Probably as you expect, many of them are men across all age groups. Here I have along the x-axis. And women seem to be getting into data science in the younger cohorts rather than the older ones. Yes, you can see this. Okay. And so it's a data science survey, but a lot of different people with different job titles identify themselves as data scientists. So you have 20% of students, you have software engineers, you have research analysts, business analysts. And I think most people in academia don't realize how much business intelligence and data science happens in the business world. So people doing project management, data engineers, and surprisingly statisticians are only at 2%. So that's not what I expected personally. Probably a lot of you want to know the academic background of people who identify as data scientists. Likely because this is a machine learning heavy survey, you're getting a lot of people from computer science. But there are also, business, math and stats, life sciences, social sciences. So there is kind of quite a diversity, and the only thing you don't really see represented here is the fine arts. So this sort of biggest myth is that you need a PhD to become a data scientist, and only 14% of people from the survey, said they held this PhD. And I agree with the results that a master's seems to be the sweet spot for a data science career, because you have probably enough of a background as an undergrad to give you a broad sense. And then that master's is a great time for you to get technical skills and kind of hone in on completing a research project from start to finish without becoming overly specialized in a single topic and narrowing that path a little bit too much. I think the myth too is that everyone else has been coding for a bazillion years. And that's not true. Most people have been coding for under 2 years in the survey. So if you're not behind, there's still time. Here I wanted to show that while Python is an extremely common programming language used in data science, that most data scientists use a variety of tools in their tool belts. And so most people are using basic statistical software like Excel and Google Sheets. So these are tools that you've likely used in your own work. People are using development environments, so that's like RStudio or Jupyter notebooks. Again, these are a little bit skewed, these results, but roughly half of respondents said that their organizations were using some form of machine learning in some form, right? And the 47% here includes people who are learning about machine learning and kind of organizations who describe themselves as moving towards AI in their organizations, which is extremely common and makes me laugh a lot because everyone's trying to jump on the bandwagon, but a lot of organizations have no need or capacity for machine learning with their own data. And so I think the final one is that like data science challenges are all analytical. And so I think this survey didn't ask people how they were spending their time, so I launched a quick survey on Twitter. And so it's about, of the people who code, how much time do you spend cleaning and processing your data? And most people spend half or 3/4 of their time. And that very much lines up with my own experience programming and the experience of my team. Most data that you will use outside of a basic stats class is going to be a mess. You're going to have lots of missing data, lots of miscoded variables, things that will need substantive expertise to go back and clean and make sense of. You cannot take the average data set and dump it into a machine learning algorithm and crank the chain and expect something meaningful. Data's messy, data's complicated, and it takes someone who knows what they're doing in terms of that data set to make sense of it and analyze it later on. Yeah. And so here, dirty data was identified by Kagelers as the biggest challenge, and the rest of these struggles are organizational. And so most people, despite the fact that there's a lot of data scientists on the market, there's a lot of unqualified data scientists on the market. Most organizations are saying like, oh, I have all this data, but management doesn't actually give me a clear research question to ask. There's not a lot of money to do the kind of methods we want to do. The results that they produce are not being used by management to inform decisions, so I think that's frustrating when you think about having spent all this time to learn these fancy algorithms, and ultimately management wants you to pull the prevalence of the people who converted on a website. People were concerned about privacy issues, limitations of the tools that they had at their disposals, and things that are very much part of the workplace and not so much part of the tools or a lack of learning or their own inability to analyze the data that they have available. And so I hope in some ways that this gave you a more realistic view of how data science really looks, and that transitioning now and talking about that becomes a little bit less overwhelming. And so you're here because you know that there's jobs and you're excited to figure out what you need to learn to move on to the next step. But the key to me is not necessarily just focusing on your technical skills and trying to figure out whether you need to learn R or Python. It's understanding the currency of the new domain that you want to go into. If you are coming from academia, on your CVs you probably have poster presentations, class projects, if you TA'd or RA'd, published papers maybe. And so those are the things that are valued and used as currency in the academic sector. When you transition, whether it's to an NGO or government or the public sector, you have to understand that they are going to have a new currency, and that it might be publications, but it might not. It might be skills, it might be grant writing, and so you need to understand and find out first what the currency of that new sector is and how to translate the language of your CV to the one of the sector that you're trying to be in. And ultimately, not everything that you've done so far or accrued is useless at all. You have to be happy about the fact that you know if you're here in this room, you are good at critical thinking, you have communication skills. If you come from a substantive background, you have domain knowledge, that's really valuable. You have an intellectual curiosity that teaches you, yes, I like learning, I know how to learn, I can gain new skills if I put my mind to it. So I'll talk a little bit about the different ways you can gain more skills. And so through courses, the American Statistical Association kind of came together with industry experts and private sector and researchers to say, like, what are the things, what is the toolkit of the data scientist? And so the courses that you can take, and I think Derek did an amazing job at telling you about courses that are McGill specific, and I'll just tell you about what to look for in a course. And so definitely an introduction to statistics. But data analysis in the real world is probably the biggest thing I can suggest to you. Find ways to use real data that is dirty, that you'll need to learn to wrangle. Using tools for data wrangling is super important, and automating those data wrangling procedures. That is probably the biggest, most powerful tool that you can gain. So, find classes that, yes, you need to learn math and algorithms to understand a little bit of the backbones of the methods you're using, and sort of becoming exposed to modern tools used in data science. Don't get too hung up on necessarily which tools, because that's going to vary tremendously. If you want to go to a government job, they're likely going to use SAS. If you want to go to a tech job, they're probably going to use Python. If you want to go into the health sector versus finance, like every domain will have their own tools. Learn one, get good at it, learn to wrangle data in that language, and move on. You should definitely become familiar with data ethics. What is the right way to think about privacy issues, both at the personal level, how we can scrape data, what's the best use of our data, not just treating data that comes from other people as sort of anonymous faces. These are things that are not often taught in sort of the more flashy data science courses, but something that's extremely important as you go into the real world. And I think, understanding how to be actively learning. So that means collaborating with other people who have different levels of technical skills than you, or who have a lot of domain knowledge, and needing to communicate with them and solve problems together. That might not be something that most people who are kind of in a siloed program will have experience with, but find courses that allow you to interact with people from different domains. So I really like this list, but the one thing I would add to it is study design. So understanding the data generation process, how the data was collected will directly inform the research question that you can ask from it and the type of analysis that is suitable and appropriate. So there's lots of pros and cons for the different strategies of learning, right? Like, so a massive open online courses are great because they're low cost and low commitment. They have tons of options for beginners. But it might be slow for you if you're sort of trying to fit this in around your schedule, and they don't necessarily hold a lot of credibility on someone's CV, because any employer knows that, like, anyone can say they've signed up for 10 MOOCs, and it doesn't really suggest or prove any sort of actual skills. Boot camps, which you'll see especially in the US, there's a lot of them and more in Canada, can be short and intense, so sometimes 2 weeks up to 16 weeks. They can be extremely expensive. Some of them are tens of thousands of dollars. The benefit of these is that they're often subsidized by large corporations, and they work kind of as like a direct job placement. And so the metrics of success for a lot of boot camps is how many students they're actually able to place into jobs. And so if that's the kind of work you're looking for, then this can be great. But again, a boot camp may not necessarily be recognized by a different employer as, proving that you have gathered skills. More and more universities are offering certificates, McGill included, and so this is nice because you can supplement an existing degree, so retain that domain knowledge that you've accrued, and it is shorter and less expensive. But certificates tend to be very general. They are not going to make you a professional programmer. They're not going to teach you how to be a statistician. So it's kind of giving you an overview of data scientist. You become like a jack of all trades, master of none. And finally, doing a proper MSc, sort of in data science or something related. And so here, what's nice is that you'll likely gain a lot of research skills and have an independent project, and you get to leverage the university name and degree recognition. So this is probably the most reputable way to show that you besides actual experience, to show that you gain knowledge. But master's programs can be slow to update curriculum, and they can be quite siloed. So imagine in a data science master's, you might not be able to be exposed to classes that are in different faculties because of the limits in the number of credits you can take outside of the degree program. And so here, this is just for your general knowledge. I provided a bunch of hyperlinks to some of the data science learning resources here in Canada. There's much, much more in the US if that's what you're interested in doing. Maybe beyond courses, the biggest thing, and I think speaking as an employer, is being Googleable and having a portfolio that you can show and prove to a potential employer that you have technical skills. And so whatever code that you can pull together from a course, from a Kaggle, from a bootcamp, make a GitHub account and post it there and provide that link on your CV. That's the best way to show someone your level of technical skills. You can build a personal website to even sort of jazz up a little bit that portfolio, show people what you're interested, tell them stories. You can write a blog post. And so that's a less time-consuming way to showcase your work, but a good way for people to get a picture of you before having met you. And again, like Kaggle competitions are a nice way that the data sets are available. You'll see kernels, which are kind of like pieces of code that other people post so that you won't have to necessarily do all the data cleaning all yourself. So it's a kind of a nice way. You can build teams, participate in a competition, maybe win some money. Local meetups are also a great way, sort of low cost, low commitment. The Our Ladies meetup, hosted by myself and Catherine, is a great place where we do workshops every month. It's sort of focused on minority genders, but men are welcome as long as they're accompanied by someone from a non-majority gender. Data for Good is a really cool one because every month they get together and they get data sets from sort of normally nonprofit organizations who don't have enough money to hire a data scientist. And so then as a group, they'll try to analyze the data for this organization and sort of provide insights. And this one's really cool because you get people from all diverse backgrounds trying to solve the data problem together. So you risk learning a lot and being able to collaborate and build a portfolio from that. PyData, so it's a Python meetup, is also really cool. Internships are obviously a natural thing, and unfortunately there's probably not enough positions for everyone in this room, but it's a great way to gain relevant experience, learn about an industry. Maybe you'll realize that you don't like it, you don't like the pace, you don't like how people operate. Check out your university co-op programs. Evido Labs, which is, I think here in the Myland, they were having on the 29th an internship event, so please check it out. Plotly is here in the other room recruiting for interns they have cohorts every summer of interns to work on their visualization platform. It's a very cool company. And so reach out to people and find out what they're offering and what they can accommodate. You'd be surprised of how big your network actually is. Okay, so this is going to get a little bit text dense, but feel free to refer back to these slides a little bit later. And so your cover letter is a great chance to explain why you're applying for the job, even if you don't have a perfect match for your own background. And I used to think that cover letters were sort of useless, but now as an employer, as I see and read a lot of cover letters, it's remarkable how bad and how little effort people put into it. So already, if you can write a cover letter that is tailored to that employer, you will be miles ahead of the curve. And instead of focusing on the highlights of your academic career and all the value you accrued and that currency, like I said, that you've accrued during your academic career, explain why you want to work for that company and how those skills translate to value for them. I can't tell you how often I have people tell me for 20 minutes how their CV and their academic work and their publications, and they have nothing to do with what our company does. And it's really difficult as an employer, because you're like, I want to offer you a job, but what you're telling me is that you're not qualified, because they're singing the praise of the work on crocodiles they did, and I do health data science. So make sure that you understand who you're talking to and that they're trying to find out if you're a good fit for them as well. So learn their jargon, learn their language, and tailor your CV to what they are doing. Keep it short and sweet. So unlike a professional CV is supposed to be highlighting your technical skills. An academic CV would contain all your poster presentations and publications. The average employer does not need to see that if they're in the private sector, unless it's 100% relevant to the job. When we post a job for a data scientist, we'll get hundreds and hundreds and hundreds of applications. And if I see a 10-pager, I just want to. So please don't do that. Keep it short and sweet. And, you're the hiring manager will love you for it. Only provide extensive detail if it's 100% relevant to the job. Tailor your CV to each application. We once received a cover letter that said, "Hi, I'm interested in working at Precision Analytics. You're a world-renowned organization." I was like, cool. That's not true. You didn't even Google us. Like, we're a startup. So don't pander. Don't use a generic template for the cover letter. Really try to tailor it to the job that you want. And these are just my personal pet peeves. Use consistent formatting, please. 4 fonts on a CV is maddening. If you're using a job aggregator site like LinkedIn or Indeed, normally there's an option to upload your CV, and then there's an option to copy and paste sort of elements of your CV into sort of the front end. Don't forget to upload your actual CV, because if you just do sort of the copy and paste, what we see is extremely ugly. That printout is awful looking. And if I'm reading 100 CVs, the ones that are like properly formatted and beautiful to look at are definitely going to stand out. And that's a bias that's subconscious, but it's real. Don't include abbreviations and technical jargon that the average person wouldn't know. This is especially true for people coming from, say, backgrounds where they've done a lot of technical work in a really specific area, using special test tubes on special cells, and the ABGR tube into the something test tube. And I was like, I don't know what that is. And so it doesn't pitch you as someone who's skilled, it's just words I don't understand. So make it general enough that a person outside your field could understand what your skill set is. Please don't indicate that you have high proficiency in 22 programming languages. You don't. No one does. And don't list 30 MOOCs that I know you didn't finish. Okay. And so searching for a position can be overwhelming because you have these different titles and they'll have similar but overlapping job descriptions. And I have a meme here because I think as of like the past 5-10 years, the data analyst position is seen as like sort of subpar, and that the data scientist and data engineer and data and machine learning engineer are sort of the more prestigious jobs. And that's not true. Focus on the skills of the job posting. Don't expect that you're going to possess 100% of the skills. It's often a wish list. Employers use really highfalutin job descriptions to try to weed out people who have no skills, which is really sad, but true. Your best bet is to try to talk to people from those companies or seasoned data scientists to get the insider perspective of what that company is actually doing and what they need. And be aware that a lot of companies are jumping on the data bandwagon without having any infrastructure to support a junior hire. So you might be dumped into a role where someone has a lot of data and they're just like, well, best of luck to you. And these job descriptions are often aspirational. You'll have to dig in during the interview and find out what your actual day-to-day is. And so during the interview, know that you're going to get technical questions and coding challenges. So it really highlights the importance of being honest about your skills. It's much better to be honest about your strengths than tell someone that you know about machine learning algorithms, and as soon as someone gently pokes, that the whole thing falls apart. We get a lot of students applying saying how eager they are to be paid to learn. So they'll say to us, I don't know anything, I don't have any experience, I've never touched a CSV file in my entire life, but I can't wait to come here and for you to teach me everything I need to know. And as like an employer, I'm like, well, this is like not a charity. So you need to show that you do bring some value, even if there's gaps in your knowledge. And be extremely ready to explain technical concepts to non-technical people. I was speaking to other hiring managers, and in an interview you might be with a data scientist, but you're also going to be with the sales department or just someone from HR. And so you have to be able to explain your thesis, if you did one, to someone who isn't in your field. We had an interview with someone who did like several years of research at the master's level, and it was about like hydraulics and pipes, and we were like, okay, well, like explain to me your thesis. And he was like, water runs in tubes. These tubes are everywhere. We need to understand how these emissions affect people. And I was like, yes. And so he had used like geospatial modeling, which is really sophisticated, and these emissions that were really niche, but he was able to tell a story to me off the bat and take my hand, because I'm tired. I've been in 4 meetings that morning, and I have 4 others lined up. Like, talk to me like I'm smart, but I'm also very tired. Jacqueline Nolis wrote an amazing book on building a career in data science. And so she does a lot of machine learning, so the book tilts that way. But she has this like great quote where she says, for the interview process, I want to hear about a project they've worked on recently. I asked them about how the project started, how they determined it was worth their time and effort, their process, their results. I also asked them about what they learned. I gave a lot of answers from this question, if they can tell a narrative, if they can relate a problem to the big picture. And so this is really important. Data science is storytelling. It isn't just an algorithm that you're implementing. Before a data science runs any model, there was an entire team of people collecting data that you need to know and understand. And then after the model is run, there's an entire team of people who need to make a decision based on that model. So it is an entire continuum of things. And so to be mindful that that's what you should be focusing on, that you know how to tell a story using data. And so after the interview, especially if you are new to the job market and it's your first time interviewing, ask for feedback. So, write a thank you email afterwards and say, hey, I'd love to hear your thoughts and feelings about me, my strengths or whatever. And so hopefully you'll hear back. There's no guarantee, but it can be a good way to see how the way you're positioning yourself is landing with the interviewers. This slide, I wasn't sure I was going to include, but I decided I should, is that from the employer's perspective, this is what we're worried about. We're worried that the undergrads and masters will have no relevant experience, that they'll expect a lot of hand-holding, and that training will be expensive and time-consuming. For PhDs, it's a little bit different. We're worried that their experience is hyper-focused, that they won't be used to collaborating with teams, both teams of people who are as technical as them or have completely different skill sets, and that they all need to still work together, and that PhDs and postdocs are often overly and underqualified. And what I mean by that is that someone who does a PhD, and I can say this because I have one, so there's no shade here, is that you'll have 5 or 6 years doing something incredibly specific, and you'll get really good at it. But PhDs will come out with like the rhetoric of, oh, I don't know about anything else. They're like, if you ask them about a different kind of cell in the same disease, they're like, no, I couldn't possibly speak to that. And so they'll have a lot of skills, but that don't really generalize. And so it doesn't mean that you can't apply for the jobs. It just means you need to get ahead of these fears, address them directly in the cover letter, during the interview, and say, yeah, maybe I'm hyper-specialized, but I really want to focus on this. I taught myself this skill during my PhD. I know how to learn this X amount of things. Talk about the value you brought and can bring to the organization, rather than just harping on your own very niche expertise if it really doesn't coincide with the needs of the company. And so back to my little Venn diagram. So we know data science is this mix of like math and stats and programming and domain knowledge. And I'm 100% sure that everyone in this room has a little bit of something in here. you guys can all see where your skill set fits in one of these circles. So trust that you have the knowledge and expertise in one of these. If you have no sort of technical background, like a lot of people from like humanities, maybe social science, maybe liberal arts, trust that you know something, and then find people who are in that domain but using data. So don't make the leap so huge. If you come from poli-sci and you wrote a very theoretical paper, don't go to fintech and say, I'd like a data science job. Be confident that you know how to learn. Be ready to start at the bottom. This applies especially to the PhDs and postdocs who might have, really excellent work and, written a lot of papers. But if you're, first few months learning R, you're not going to get a managerial position. You won't be leading a team. So just understand that if you're making a huge leap, that you'll be starting at the bottom. And just trust that your path is the right path. There is no straight way to get into data science. That might be not comforting, but hopefully it's comforting because it means there's no wrong way to do it. And so a big thank you. Catherine and I are at a booth in the next room. We're looking for summer interns and potential academic collaborators. So a big thank you to the Center of Social and Cultural Data Science for inviting me and Reddit's Data Science and for all their memes. You can find me on Twitter. The presentation was written in R. It's a little flip there. And can be found on this website. For those of you not familiar with R and slides and GitHub, all you need to do is go to the link, download the entire repo, and it's the HTML file. And so I'm happy to answer any questions, unless it's about the R versus Python debate.
Thank you so much. Anyone have any questions? You can come up to the microphone.
I can speak out loud.
So no one can hear you.
So you said that while you're doing your PhD, you reached the tipping point of do you want to continue it or not? And then after you moved on and said you started your postdoc. So how did that work out?
It was just through sort of a soft landing. I think I can tell everyone the big secret is that postdocs are can be an informal soft landing after a PhD. I did some work with a researcher in Toronto, and it was kind of like committee members who made calls on my behalf. And I was like, hey, I have someone who could do some work for you. And so it was like very informally arranged. And so they were not postdocs that had been formally applied for, and that I was kind of like on the sure track for academia. It was work that I really enjoyed doing, and that I was willing to continue as I was trying to figure out what the next steps.
And from the beginning of the time when that fear arose in you until the time you started actually, you felt that you're working in data science, how long was that process or period?
I mean, like most of you, I was using data during my undergrad, so I was using SPSS because I was in psych, and that was kind of the tool that we used. So I used SPSS for my psych and masters, and then for my PhD I started in Stata, and then I taught myself R during my last year because I wanted to learn how to use a ggplot, so those great graphs that I made in here. And then I learned R on the job, basically. So
Thank you.
that doesn't answer your question, but it takes years.
Yeah, so for people who are earlier in their undergrad who are trying to find internships or whatever but don't have loads of work experience, which things do you think are most important to highlight in a CV or cover letter?
Are you talking zero data experience?
Or minimal or very minimal?
So if you have any data experience, like I said, build yourself a portfolio where people can see what that looks like. If you are in the middle of an undergrad and you've never worked, it's hard for someone to assess, and you might not be able to report exactly what you did learn because it's just coursework. So have that portfolio as a way to show proof.
Thank you.
So I'm a PhD student, and I've done R programming, Python programming. I'm pretty confident in my data science skills. And I noticed that AWS offers a lot of courses, like cloud computing, for example, but those aren't quite MOOCs, but they're not quite boot camps, and I just want to hear your opinion on those and how they can maybe help the transition.
Like, I wish I could speak to every single one of these courses, and I think, like I said, it's going to be hit or miss about whether an employer recognizes that as something valid. I think, and whether they use AWS sort of in an organization as well. If you're working at a hospital, they're going to be like, this doesn't matter to me. But in a tech company, it might matter more. And so I think it kind of depends. You can do it, and as long as you can prove that you learned something from that, then it doesn't hurt or harm you. But just know that the ROI might vary depending on where you're going next.